Okay. um, all this warm up had you do was use the Pythagorean theorem. A little bit different than the warm up we saw on block day because this time we knew the hypotenuse. So this was more thinking about with the Pythagorean theorem, where do the legs go in that formula and where does the hypotenuse length go? Again, just remember we always need to set it equal to the hypotenuse length. Okay, now how you kind of lead up to this, I let that missing side equal x. You could have put BC. That part isn't really all that big of a deal, however you label it, as long as you're coming up with it being 8. Okay, worked out really nice. But just want to remind us that anytime we get square roots to show up in this whole unit, we need to reduce those down. If square roots show up in the denominators, because we're going to see a lot of fraction work, maybe not so much today, but to also reduce those down as well by rationalizing denominators. Okay, all the square root stuff we want to continue to work on. Any questions here before we just give some reminders about right triangle trig? Yeah, Leah. What do you mean? Oh, like the negative root? Correct. Right, yeah. There we'll get some negatives eventually. But if we're just strictly looking at a triangle, right, when we measure length, length will never be negative. So for now it'll be positive. No, no, no. Good question. Okay. Um, we're gonna start out by just introducing the 6 trig functions. 3 of these we already know. Now, I do want us knowing the names and pronouncing them correctly. Okay, so as we kind of get going, so frequently I'll hear students say, oh yeah, sin of whatever angle and cos of whatever angle and tan. Okay, let's make sure that when we see sin, we know that it's sine. When we see cos, we know that it's cosine. Tan is tangent. Okay, so if you don't know those, I would write them down. And then probably new to us are what's called the reciprocal functions. And let's label that here. These are called the reciprocal. Okay, meaning they are the reciprocals of the original 3 trig functions. So cosecant, technically, and we'll get to all of this here in a second, cosecant is the flipped version of sine. So it is the reciprocal. So sine and cosecant are reciprocal functions of one another. Cosine and secant are reciprocal functions of one another. And cotangent and tangent are reciprocal functions of one another. So at least the cotangent one, in terms of the naming, makes sense that it's the reciprocal. It can be kind of misleading that sine and cosecant are the reciprocals, and cosine and secant, because it would make more sense for sine and secant to be the reciprocals. They both start with an S, but for whatever reason, it just is naming. For the naming, sine and cosecant are the reciprocals. Okay, so important for us to know that. We will do some work with all 6 of those functions today. And eventually we're going to work on, I believe we'll graph all 6 functions as well. Now, the word reciprocal is important here. They are not the inverse functions. That is different. We will talk. In fact, I think we'll probably get to that today about what the inverse functions do. Inverse functions basically undo any operations of what we take sine, cosine, and tangent of. So it allows us to find angles. Okay, so reciprocal, inverse, very different there. All right, so again, make sure we're working on using the correct names, not just saying the abbreviations, because we see the abbreviations more as we do the work, but I still want us actually knowing the full names of them. All right. Brings me into the next point, which is when we're dealing with right triangles, we can use SOHCAHTOA to find whether that be side lengths or even angles. Okay, so we kind of did this in our warm-up yesterday. If it's been a while for you with working with right triangles, probably a good idea to remember that based on what theta is, which side is opposite, which side is adjacent, and which one's hypotenuse. Okay, that we have to have that down. It's not a hard thing to figure out, but if you don't spend the time just kind of processing it, you'll run into some errors there. Okay, so for me, the side opposite, if I draw an angle, or if I have an angle and just draw an arrow straight across, That's the opposite side that I'm looking for. The adjacent side is always touching the angle, meaning it helps form it. And then the hypotenuse in a right triangle is always across from the 90-degree angle. Right? So again, this was part of our warm-up, the SOHCAHTOA. So let's just kind of remember what SOHCAHTOA is. And I want us to think about them as ratios of trig functions. So if I take sine of an angle theta, that variable is theta. So sine of theta, it is equal to the ratio of the opposite side length divided by the hypotenuse side length. And really important that we understand both sides of these equations. Okay, that sine of an angle is equal to ratios of side lengths in a right triangle. So that's the sine equaling opposite over hypotenuse, the being cosine of the angle theta equaling the adjacent side over the hypotenuse side. And then the TOA is tangent of theta equaling the opposite side over the adjacent side. And you know what? Let's just go ahead and add on to this and talk about what the reciprocal functions are. I don't have a place for that in these notes, so I'm going to just use a sticky note for this. Okay, so just kind of extending this into those other three reciprocal functions. So first, knowing that the reciprocal of sine is cosecant. So cosecant of theta is the reciprocal values of what we have for sine. So cosecant of an angle is equal to the hypotenuse side over the opposite side. Inverse, or excuse me, not inverse, but reciprocal of cosine is secant. Secant of the angle is the reciprocal ratio, so hypotenuse over adjacent. And then reciprocal of tangent is cotangent of the angle, being equal to the adjacent side over the opposite side. Right, so as we move forward, we'll focus more on the three original functions. There's going to be some memorization with all this trig stuff. I focus on knowing these three and then just knowing which reciprocal function corresponds to which original trig function. And then I just know that it's the flipped version or the reciprocal of those values. Okay, so important to make those connections and kind of limit all the memorization, but again, there's going to be some. Yeah. No. There is not a button on the calculator for cosecant, secant, and cotangent. We will talk about how to put those values in the calculator. It's going to end up being like 1 over sine, 1 over cosine, 1 over tangent. That's another way to do reciprocals. We'll get to that here in just a little bit. All right? Great question. Okay. Well, let's go ahead and, within a right triangle, find all 6 of the trig values. In fact, why don't you all try right now? You have all the information. We're missing a side length. Is that the same triangle from the warm-up? It sure is. So let's save ourselves some work and some time. Since this is the same triangle, let's call this 8. And based on this angle theta, I want you to find sine of theta, cosine of theta, tangent, and the reciprocal values as well. If reducing down is required, make sure we reduce down. Give it a few minutes to work through this. Okay. Actually, not much work that we needed to do here. It's more just understanding those relationships of which side length corresponds to what. There's no reducing down. More than likely, if you get something wrong on Math Excel, it has to do with reducing down of these values. Okay. So you can go ahead and check this. Again, I start by finding the 3 originals. So sine being opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Then for the reciprocal functions, I don't even get caught up in hypotenuse over opposite or hypotenuse over adjacent. if we think about what the word reciprocal means, it just means to flip what we had previously. So all I'm doing for cosecant is flipping what I had sine of theta equal to, getting 17/8. Same thing with secant. I'm going to flip cosine to get 17/15, cotangent 15/8. Yeah, question? Almost always we'll write them as fractions. If it works out to be a nice decimal, then we might write it as a decimal. But in this class, and basically as you move higher up in math, the more exact we can leave answers, the better, which typically means leaving them as fractions. Okay? Great question. Yeah. No, the sine to the -1 and cosine to the -1, those are inverses, which are different, okay? And we will get to that here in just a bit. The inverse functions are going to help us find the angle. So if we wanted to find theta, the actual angle measure here, we would take the inverse sine of both sides, or inverse cosine, or inverse tangent, okay? All right. Try this one. See, based on this information given, using a right triangle, can you find the values of all the other trig functions? Work within your group, see what you come up with. Here's what you should have gotten. So the missing side length was √5, making cosine √5/3. Not much simplifying involved there. With tangent of theta, though, when I take the opposite side over the adjacent side, I get a square root in the denominator. We need to rationalize that, and we do that by multiplying by √5/5, making it 2√5/5. Now that I have the three kind of original trig functions, the reciprocals, this is where you can kind of think about, is it going to be easier for me to just simply take the reciprocal value of what I got before, or think more in terms of opposite, adjacent, hypotenuse side lengths? So when I look at secant, I'm like, if I just flip 3√5, that's going to work out to be the hypotenuse over the adjacent side anyways. Okay, so I have to multiply by √5/5, and I get 3√5. But now with cotangent, if I flip that tangent and just straight up take the reciprocal value here, I get 5/2√5, which requires a little bit more simplification. And so I was like, okay, because that fraction just has three different kind of numbers in there, I instead found cotangent by thinking about the adjacent side over the opposite side. And I didn't need to do any simplifying there, okay, which is just one thing that, again, I kind of knew how that was going to work out, and it avoided me doing any extra work. Now, let's say that you didn't recognize that, and you just went ahead and flipped this. That would be 5 to √5, so you multiply by √5. So it works out to be 5√5 over 2 times 5. And now those 5s divide out, and you still get √5/2. Okay, so just a little bit extra work, but you get that exact same value. And so that's something that you can kind of keep in mind. Okay, should I use just the values of opposite, adjacent, hypotenuse, or should I just flip the fraction? Okay, cosecant being the hypotenuse over the opposite side ends up being just 3/2. Questions here? All good? All right. Let's move along here. And we'll probably just stop once we get to the applications. Okay, so this is going to address some of the questions that some of you have asked about calculators, whether we can use cosecant, secant, and cotangent. And then also we'll get to, Leah, your question about the inverse functions here in just a second as well. All right, so let's have everybody grab a calculator. And you know what? Maybe I'm going to go grab some of the other calculators. All right, the first thing that we need to pay attention to is the mode that we're in. Every calculator is able to switch between degree mode and radian mode. So it's important that when we're working with trig functions, before we even get going, and this is kind of more along that conceptual idea that I keep putting on us, thinking about, okay, am I working in degrees or am I working in radians? Sine of 38.3 degrees, okay, we're going to almost always see that degree symbol when in degrees. So here's how we can check this. Every calculator should have a button that says mode somewhere on there. For these graphing calculators, it's up at the top left. And when you press mode, there's a lot of different things we can switch between. We're just going to focus on the radian and degree modes here. So we're going to go over to degree, make sure it is highlighted, and press enter. And then you can just simply press clear to get back to the home screen. And now we're going to go ahead and find, let's just do all the ones that are in degrees right now, and then we'll do the ones in radians after. Come on, focus. There we go. All right, so sine of 38.3, you're going to hit your sine button. Should be pretty easy to find. Sine, cosine, tangent, all kind of line up next to each other. 38.3, and I get 0.619. We're going to round to, what does it say, thousandth. So 10/100th, that'd be the third decimal place. So this would be 0.61, because we'd round the 9 up to a 0. So it'd actually be 0.62. Now, when we get to these reciprocal values, and this kind of brings up the idea of reciprocal, again, with triangles, we can just flip the ratio of the side lengths. If I want to find secant on the calculator, though, I first need to think about, what is that the reciprocal of? It's the reciprocal of cosine. One way to also deal with reciprocals is to put 1 over that original function. So secant is equal to 1 over cosine. So for us to find secant, we're going to take 1 over cosine of 53.2 degrees. That's how we can plug it into the calculator. There is not a button that simply takes the secant. It's 1 over. 1 over the value is another way to do the reciprocal. So even if we went back to the, in fact, let me just show us this real quick. If we know that cosine of theta is the adjacent side over the hypotenuse side, and let's say I want to find secant of theta. Well, if I know that it's 1 over cosine of theta, I can take 1 over the adjacent side over the hypotenuse side. And when I do this division, it's 1 times the reciprocal of the denominator, making this 1 times the hypotenuse over adjacent. 1 times anything is just what we started with, making secant of theta the hypotenuse side over the adjacent side, which is what we had down previously when talking about triangles. Everyone following with me there? Okay. Awesome. So in the calculator, I'm going to go 1 divided by cosine of 53.2 degrees to the nearest thousandth, so that'd be 1.669. Cotangents, we're going to do 1 over tangents of 12.3. So 1 over tangents. Oops. Is 4.586. Okay, and then the last 2 values we have here are going to be in radian mode, right? So let's go back into the calculator, switch into radian mode, which we can do by pressing mode. Again, scroll down to where you see the radian and degree options. You're going to press enter on the radian, so it is highlighting the radian. And then you can press clear to go back to the home screen. And then we'll start with tangent. So pressing tangents. And then on the graphing calculator, the pi button is the second option of this exponent button. So you'll hit second exponent to bring in pi, divide it by 3, and we get 1.732. Right, to do cosecant of pi over 4, once again, we need to do the reciprocal. Cosecant is the reciprocal of sine. So I'm going to do 1 divided by sine of pi over 4. So in the calculator, 1, oops, wrong button, divided by sine of pi divided by 4 is 1.414. There we go. So all of these decimals would be equivalent to, if we were working in a triangle here, those opposite adjacent hypotenuse sides and whatever ratios that might end up being. All right. Any questions about doing things in the calculator or how I came up with any values here? Bless you. Okay, I think this is a good stopping point for us. The only thing we did not really get to are applications involving right triangles. Those will show up on your Math Excel assignment. I am realizing I made that due date Tuesday. Since we're going to do the applications on block day, I'm going to push this back to be due on Wednesday, just so that the second period class can also get some practice with the applications, right? We have about 10 minutes left in class, so find something to work